Hi, everyone. I'm Peter Burns, an automation specialist at Turtle. Today, I'll be covering the 5032. This is a on-machine I/O. Uh, we'll be going over the technical details, so I won't give away too much right now. Everyone can see this? If no one says anything, I'll take that as yes.
It's a yes. Thank you.
So once again, we're going on the ArmorBlock 5000 I/O. Here's a quick agenda for the day. It'll be about a 30-minute presentation. We'll go over an overview at what the ArmorBlock 5000 I/O Link Master is, the ArmorBlock 5000 I/O 16-point configuration block. They look very similar, but they have some different technical details, and some sample architectures of the ArmorBlock 5000 and some additional resources. So here's a quick overview of the ArmorBlock 5000 I/O. It is a simplified offering with extended features such as timestamping, event triggers, and more. These are both IP66, 67, and 69K rated, meaning they're suitable for high water pressure washdown applications. So you can put this in a environment where you need to clean all your equipment, so like medicine or food. There's also a lot of flexibility with the installation. They can be zero stack, so they can be touching each other side by side, and they can be mounted in 6 different orientations, facing down, facing up, on its side, upside down, however you want to orient it. There's consistent I/O experience with common data structures using the 5000 I/O channel data structures. It's also a more secure design with stringent design process and security capabilities such as a secure web server and custom IP addresses to minimize the security risks with a device which is connected to Ethernet. There is visible indicators. So these are LEDs positioned. Sorry about that. I'm just going to mute my phone. So there's LEDs positioned right next to the inputs to the ports. These guys will be able to communicate whether or not a port is on or whether or not it's getting signal back. So introducing the ArmorBlock 5000 on-machine I/O platform. These guys have dual Ethernet ports at the top. So this allows you to support ring or DLR topologies. So you can pass Ethernet through these devices and keep going forwards. These are based off of 4-pin M12 decode connectors. With the M12 connector, you get that washdown rating. However, it won't. You will need either an adapter or the right cord set in order to plug into a standard Ethernet jack port, an RJ45 port. There is a 8-port design. They all use 5-pin M12 A-coded, so that are going to be the ports down the body. There is dual power connector at the bottom with 3 variants. This also allows power to get passed through these devices, so you can daisy chain multiple of these together. They have an operating temperature of -40 up to 60 degrees C. There's a shock rating up to 30 G and vibration rating up to 5 G. The I/O Link Master comes in 3 different SKU numbers. The difference of the SKU numbers are just going to be the different types of power ports at the bottom. And then the 16-point configurable, the 16-point digital I/O also has 3 SKU numbers, which would also just be the difference of the power cords on the bottom. So let's go a little bit more into the I/O Link Master specifically, and we'll get to the 16-point digital block later. This is a highly configurable model. There is 8 I/O Link channels, 12 CF configurable channels, 4 digital in-out channels, and you can select a combination of whatever of these combinations. There is one per port. There's 1 I/O Link channel, and At the top half is going to be class A ports, which will be about 0.5 amp rating, and below will be class B ports, which will be 2 amp ratings. These guys are designed to work with the 5080 controllers or better, and will need a version 35 or better Studio 5000. So going a little bit more into the ratings, they can deal with 0.5 amp per sensor. They can put an output of 0.5 amp. They can have for the class B ports, they can do a high output of 2 amps. They can do a simple counter up to 2.5 kilohertz. And class B ports can either do 0.5 amp or 2 amps, depending on your configuration settings. The I/O channels have built-in overload protection and short circuit protection. There's also diagnostic to go with this, so it can feed back that information to your PLC and tell you what's going on. And there's 2 power variants, which will be 10 amps and 16 amps. They can put out 10 amps per block. So if you're going to daisy chain these and you want to use the upper limit of power, you're going to have to use like the L code to get the 16 amps through one device and onto the next. Locally, these blocks can modulate sensors, actuators. They can do local actuators with galvanically isolated. They can also have built-in reverse polarity protection and over voltage protection. So you're not going to have to worry about these guys, catching on fire if you backdrive a motor. They use IO-Link version 1.13. They support Class A and Class B, as we mentioned. Those are built in. There's a fallback mode in case this stops working for a minute. It's not going to fault. There's IO-Link event logs. There's configuration change notifications. If someone's messing around with it, it'll appear on your PLC. There's master configuration with auto discovery for IO-Link devices. So as soon as you plug in a register IO-Link device on Studio 5000, it'll ask you if you want to add that device. You can register IODD files, and IOD files will auto-generate tags so you don't need to tell whether or not the sensor is on or not. There will already be a tag generated for it. They can be configured either online or offline, and you can rewrite the parameters, forcing bits to toggle. There's extended features such as precision time protocol, module diagnostics with timestamps, IO-Link event logs with timestamps. There's rising or falling edge timestamps, and electronic keying for IO-Link devices. Some new enhancements compared to the 1732 is there is a secure web server. So if you punch in an IP address, you can actually log on to this device and do some configuration locally. There's explicit messaging of the device. You can upload embedded IODD files from Rockwell Automation devices, and you can deal with firmware updates for Rockwell Automation devices. So if you have a sensor that needs a firmware update, you can do that through this. The IO-Link device, the ports can be set into 2 modes, either IO-Link or digital channels. When you have these different settings, they're going to have different speeds. So the minimum RPI for IO-Link will be 200 microseconds. The minimum IO-Link device of RPI is 1 milliseconds. The IO-Link cycle time is up to 1 milliseconds. The timestamp accuracy is less than 2 milliseconds. When in digital channel mode, the RPI will be 200 microseconds as well, but input response time will be 350 microseconds, a timestamp accuracy of 200 microseconds, a pin 2 output response of 400 microseconds, and a pin 4 output response of 600 microseconds. These pinouts we'll go over in a second too, but the pins, when in digital output mode, it splits one port into 2 outputs. and those pins are going to be the different sensor inputs or outputs. So as I was saying, here are the port configurations for the Class A ports. That's the ports on the upper half. You can see the wiring codes at the bottom. I feel like I don't need to read those aloud. And then for the bottom half, that's going to be your Class B ports. Since the Class B ports can do extra current, they have the extra fifth pin is going to be used, where on the Class A ports it's not being used. The Class B ports are going to be better for powering devices such as like a tower lamp, while the upper A class ports are going to be better for sensing devices. But you can do either with each. It just depends on how much current you need for your application. So you can seamlessly swap an IO block 5000. So if this guy dies, you can run over, grab another one, and throw it onto your machine. The only thing is you might need to set up the IP address to be the same as the old IP address and change the configuration if the modules are slightly different. So in Studio 5000, you can just swap the different power variants. So if you want to go from the 10 amp to the 60 amp, you just change that. And there's no need to change any names or replace the tags. Using the local secure web server, you can access using a web-based browser. So you punch in the IP address, that'll sign you in. If you have a passcode on it, you'll need to sign in to adjust any of the settings. This supports self-sign, RSA, and ECE certificates. You can configure and monitor the modules via this secure web server. You can also have improved security with this IP address because you can customize the IP address. You don't need to use the basic subnet of 192.168.1. Once you log in, you can adjust this to change that first, second, or third subnet to whatever you desire. Even at the Tomorrow Lab, we have the third subnet changed, so we don't need to interact with our primary network. And then this allows for easier troubleshooting if there is a problem at hand. So the integration experience, this allows you to have increased flexibility. You can have optimized productivity because if it's down, you can just throw it on, and a total lower cost because you're not running giant wires. You don't need to worry about as much setup time for other standard devices. The IO-Link 5000 enhancements, there's some software enhancements with, you can download the IODD files for unknown IODD files, so it will find it for you. There's the ability to swap to other power variants seamlessly. So if you don't like these cables, you can just throw a different one on. And you can also import or export all your EDS files and IODD files if you want to move this from one block to another. Some firmware and software enhancements are there's generic IODD files are supported for all devices. So other companies that make devices that use IO-Link can now be supported on here. It supports process data only mode, so there's different configuration settings that we'll go into a little bit, and data process is one of them. IO-Link Master is embedded with us, the web server, as I mentioned earlier. There's explicit messaging from the device, so this will message directly to your PLC. And you can upload embedded IODD files supported for all Rockwell Automation devices. The IO-Link is highly integrated. Using IO-Link is very similar to Ethernet IP. So IODD files are going to be like add-on profiles, and there's a common interface with IO-Link devices, making it easy to communicate between all of them. It's more adaptive. Once again, the IO-Link is like Allen Bradley's Ethernet drive, so If you set up anything that uses Ethernet, IO-Link is going to be a very similar process. There is improved productivity with optimized workflow using Studio 5000 Logic Designer. You can automatically fetch IODD files for unknown devices. You can import or export EDS or IODD files. You can swap between different powers variants seamlessly, and there's better synchronization for backups or duplication of a system onto another machine. IO-Link integration allows device trees to provide an overview of all the IO-Link devices. So it'll appear like a Ethernet configuration at the bottom of your Studio 5000 on the bottom left-hand side. The add-on profile can be configured to monitor or correlate IO-Link devices parameters. There can be descriptive inputs and outputs, configuration tags to configure the IO-Link devices. IO-Link is also highly adaptable. It allows streamless workflows for configuring devices from both in the field and through software. And there's 3 levels of device integration: ADC, device storage, and generic IO-Link devices. There's enhanced productivity. It all uses one software to manage the entire project. That would be Studio 5000. You can automatically download IODD files from IOD Finder, and you can also export these EDS files. So I mentioned earlier, there's different device configuration. There's automatic device configuration mode. The controller will validate the IO-Link devices, will name and configure the process data tags. It will automatically restore the device configuration from the controller and configure the device parameters through an add-on profile, configuration tag, and explicit messaging. Another mode is device storage mode. The controller will validate IO-Link devices. It will name the process data tags. It will enable DS mode for processing data only, and it will configure device parameters through the add-on profile with explicit messaging. And then a third option will be generic IO-Link devices, where the controller does not validate the IO-Link. It just processes the raw data tags and configures the device parameters through explicit messaging and does not support ADC or DS mode. So you'll need to write all your tags locally on the PLC. And for the IO-Link mode has another 2, ADC and data storage mode. Here's a little bit better illustration. So with ADC, it will automatically restore device configuration from the controller. So information will feed from the controller into the 5032, then into the device, and then it will feed all that information back to Studio 5000 and tell the device how it's set up. However, there's also data storage mode. So it'll read the information from the 5032. It'll take the teachings. If you taught your sensor locally, it will then send that information back to the 5032, and then it will update the Studio 5000 and your PLC to use that teaching tag rather than your PLC setting. And using the IO-Link, the 5032 IO-Link, this software is easier to set up compared to our competitors' IO-Link master block. Our steps it'll take usually about 6 steps to set up the IO-Link master block with Studio 5000, but using a third-party system will take usually 13 steps. This is a 50% reduction in effort in the setup, potentially less controller memory consumption. There is seamless configuration with one operating environment only, and automatically converts IO-Link device parameters into tags with no manual data mapping. It also only manages one ACD file for the entire project, and it's the ArmorBlock 5000 is a plug-and-play IO-Link project for middle-of-the-night replacement. So once again, if this fails, you can take the exact same block and swap it onto your machine as long as the IP address is set the same. So what are the benefits of a highly integrated IO link? It provides seamless workflow to add a new IO link device. It offers best-in-class IO link device management. It treats every IO link device like an Ethernet IP device, and it simplifies the IO link integration experience with Allen Bradley controllers. The ArmorBlock 16-point configuration block. So it's going to look almost identical to the IO block, except now it's going to be using digital signals instead of IO link. So some key points of the 16-point configuration block: there's 16 configurable digital channels, and they can be configured in an 8-channel or 16-channel mode. So each one of the ports can be either 2 or 1 digital signal. This is highly versatile for all digital applications. There's simplified offering, integrating over 10 ArmorBlock 1732 standard blocks. And this is for high performance architecture for 5580 controllers or version 35 or later Studio 5000. This guy also comes in 3 power variants, which the 3 power variants will just be a change of the wire inputs at the bottom. There is fast and standard channel ratings. Sensor power can be 0.5 amp or 1.6 amps per group. So each group will be split into halves. One half will be, so this half can only supply 1.6 amps, and this half can be 1.6 amps, but per port, it can deliver 0.5 amp. There's a simple counter that can go up to 25 kilohertz, or in the fast mode, or 2.5 kilohertz in standard mode. There's also sequence of event processing, so it can be first FIFO, or up to 25 kilohertz in fast mode, or 2.5 kilohertz in standard mode. I'll go into a little bit more what sequence of events and first in first out processing is later. The fast output can be at 0.5 amp at 8 kilohertz, and the high current output can go up to 2 amps. There's extended features such as secure read and write web servers. There's support for custom IP address settings and sequence of events, also scheduled outputs. The power variations are, once again, just to change these power ports on the bottom, with the L code being able to do 16 amps, while the other two only can supply 10 amps. The entire thing can only deliver 10 amps per block, so that would include all the ports. So if you're going to daisy chain these, and you're going to have a high amp output settings per your digital sensors, you're going to want to go with a 16 amp version in order to daisy chain that power. And built in, there's reverse polarity protection and overvoltage protection. The simple counter can support continuous or rollover operations. It can be configured to have a preset value or reset the counter programmatically. There's simple counting to measure the speed. There's sequence of event, which can store up to 256 events in the onboard memory. It can detect the sequence of events and find the first fault in the system. And it can support event retrieval by the channel. So rather than necessarily having to do everything over Ethernet IP and sending it back to the PLC in sequence of event, if it locally, if it gets this digital input, it can do this digital output. This can also, that is for enhanced speed. It's not really changed anything programmatically. And then there's scheduled output, supported for standalone, or it can work with MAOC instruction. This achieves better result with synchronization of output actuation. This is optimized for high-speed output CAM applications such as reject, gluing, printing, and cutting. So these guys can work directly with motors in doing the when I go over the setup applications, I will show a little bit more photos of this. So these ArmorBlocks are meant to go on machine because they're washdown rated. This means they're highly adaptable. Every channel can be configured as an input or output. They can provide up to 0.5 amp of sensor power. There is fast input, which can be measured conveyor speeds through a simple counter up to 25 kilohertz. They can track product and trigger events. They can pulse type of sensors, for example, flow meters. They can timestamp batches for entering the machine. And then with sequence of events, they can capture input timestamping of batches that require secondary processes. They can store the timestamp of events in first in, first out FIFO manner, simplifying the user effort to develop their own first in, first out mechanism. With high-speed actuation in a high-speed process, they can divert and sort such sampling for rejecting. They can also help with gluing or labeling. They can also support a minimum of 50 microsecond interval output pulses or up to 2 amp load. These guys can be in either 16-channel mode, so each one of these ports are going to be worth 2 digital outputs. We sell splitters for these to get divvied up easier, or it can be configured in 8-channel mode, so then each one of these ports are just going to be running 1 digital channel. That does change the naming sequences, so I'll go over that real quick. Each connection is still only worth 0.5 amp, so combining the two does not make it for 1 amp. There's different tag structures for the 8 channels, and they use only the 4-pin instead of the 2-pin. So earlier I was talking about the speeds of which the pins write, so that will affect whether it'll be affected whether if you're in 16-channel mode or 8-channel mode. And the input, it supports input timestamping for first in, first out. So you can see here on the bottom left is 16-channel mode. So the first port is going to be channel 0 and 1, while the bottom right channel is going to be channel 14 and 15. But then 8-channel mode, the first port is channel 0, and the bottom right port is channel 7. And then these will be the tags in your PLC code. So a little side-by-side comparison of the IO-Link master versus the 16-point configuration block. The IO-Link master is highly configurable with up to 8 configurable IO-Link channels. The IO-Link only supports one. It only supports 1 IO-Link per port, and there's 4 Class A's and 4 Class B. The load is the two are very similar. It can do 0.5 amp of sensor power. It can do an input counter up to 2.5 kilohertz. It can do a standalone output of 0.5 amp, or the high current Class B ports can do up to 2 amps. For the 16-point configuration block, you can have 16 digital channel outputs, either in 8-channel mode or 16-channel mode. The IO ports are faster compared to the IO-Link ports, being able to do a standard input of 2.5 kilohertz or a fast input up to 25 kilohertz. Then there's also baked-in features such as timestamping, sequence of events, first in, first out inputs. There's also, you can do 16-point scheduled output mode with, and both of them have short circuit and overload protection built in. Here you can see the side-by-side of the 3 different variations of the IO-Link and the 3 different variations of the 16-point configurable blocks. Once again, the only change is the power ports on the bottom, with the L code being the smallest ones to the right of the 2 sets. These are the ones that will be able to deliver 16 amps, while the other 2 will only be able to deliver 10 amps through these ports. So here are some sample architectures of the ArmorBlock 5000. This is using the IO link on machine. So you can see here is an example of on the top left side, it's power is being delivered one and then daisy chained to the following IO link master, rather than having a power supply for each. And then all the Ethernet is also daisy chained through each other, allowing all the IO link blocks to be connected together. This this reduces your downtime with minimal environmental risk because these guys are rated for on machine with robust insulation. So these guys can take a beating before they stop working. And there's improved scalability with easy to extend the scale as a system requirement changes. So if you want to throw another conveyor belt, all you have to do is throw another block, and then you can throw as many up to however many sensors that can be allowed per block. I'll go over that in a minute. These guys can actually handle an impressive number of devices. So this also allows for a cabinet-free design and simple installation, and the optimized productivity by reducing the number of inventory of spare parts. And you can mount closer to the devices that you're using, which reduces overall wiring. With the speed of these devices, like the 16-point configurable block, you can detect and rectify anomalies quickly. Using like the compact 3580 controller, you can develop an event task to handle diversions. This configures the event task to be triggered by the 5032 EI tag. It then uses the ArmorBlock 5000 to connect with the data events and works with the participating inputs to approve the status. So here you're getting your sensor data in, and it's talking directly to it's working as a network with these power flexes to adjust the conveyor belt speeds in order to speed up the boxes in order to keep a continuous flow of work coming out of the machine. So it's automatically adjusting the gap between these boxes. You can also have scheduled outputs for a motion use case. This uses an actuator like the kinetics, Armor kinetics drive. So this is for like a camming reference. You can configure the module to schedule the outputs, and it can configure MAOC instructions for the output. This is a fast and high current output available for the selection. And the scheduled output can activate positions between X and Y, so it can adjust that camming in order to get the boxes in the right position. The IO link uses industrial Internet of Things architectures. So this benefits you by having essential connections of everything and an easy management of the IIoT connections from a single point. This optimizes your network traffic as a process and diagnostic data already resides inside the controller. It reuses all the device name tags set up in the controller. It consolidates all your data from the entire system, including the controller, Ethernet switch, your motion system, your drives, and your motor controllers, as well as your energy monitors, your I/O modules, and your I/O link devices. All this creates a simplified workflow when setting up your IIoT connection with this is all based on the optics terminal, so this information can all feed back to there and give you status updates of all your devices. So when setting up you can set these up quickly because once you plug the Ethernet of the ArmorBlock 5000 into a PLC, they will read the IO link information back from the sensors, and they can be set up within a matter of minutes. This will track your data events, log the IO link operations via channel 0, and digital inputs with timestamp via channel 1. So here's a sample architecture of if you want to set up many devices using the IO link device. Since the Class B ports can deliver more power, this is great for tower light rather than running an accessory power. You can also do a ArmorBlock 1732IL IO hub modules as well. I'll discuss this in another slide real quick. But then all these devices, since the IO port can also be split into 2, you can see at the top right here that you actually have an actuator and sensor going to 1 port. Once again, this is going to be limited for 0.5 amp per each. And then you can daisy chain this and set up a very similar system to your right, all through the same communication port. Talking about the IO link hubs, you can set it up so with the IO link master, you can have up to 120 IO points per one ArmorBlock 5000 master. These will all have to be set up in digital mode, and you have to split up each one of these ports into 2 ports on the IO link hubs, which allows you to have 120 IO points using digital signals. And then here's just another example with you can see each one of these ports are going to have like an input output. And you're running, these guys are going to take power from an additional resource in order to run all these powers. Well, this one is not taking extra power in, but there's going to be very limited power to each one of these IO link hubs. Well, this one, you can get the full current out of each digital device. And then here's also just a setup of the power, where you'll be putting this into the IO link on one side, and then these guys will feed all these hubs through the ports on the ArmorBlock 5000. And then here are just some additional resources if you guys are interested. Does anyone have questions? You can raise your hand or just unmute yourself. Cool. Well, if you're interested in getting a ArmorBlock 5000, please reach out to Turtle. We are the Allen Bradley distributor for the larger New York City area, including parts of New Jersey, Lower New York, and Long Island. Thank you, and have a good day.
Thank you, everyone, for joining us for Talk Tech with Turtle every other Tuesday at 10 a.m. We'll see you in 2 weeks. Next up is Modern OT Network Migration with Turtle Authorized Service Technician Anthony Kapper. We'll see you then. Thank you.